people have joined the lives, but yet there's like 180 likes on this. How is it even possible? Fern, if you want to get better at it, what you have got to do is, oh, right, that makes sense, Taylor. Thank you for that. Fern, what you can do is, where is the live streams? Which topic are you doing, Fern? Are you doing algebra, calculus, or probability? Thanks, Layla. If you're doing algebra and probability, these two playlists are your starting points. So I'm doing part 9 of this particular playlist today, and I think we've got another hour, maybe half an hour on it, and then we're done with probability as well. So go to YouTube, find a level 2 algebra in 15 hours, work through that, and then find level 2 probability, work through that, and you should be good to go. It's working. What's working, Samuel? Fan, 100% you've got plenty of time. I think you've got about 6 weeks, close to 6 weeks to do this. And those playlists that I have there, once you finish these two playlists, head down to the practice exams. And I think if you go through those, you've got tons of time to finish through that. Now, I've had people that have actually got not achieved like N2s in mocks go on to get like M18 and 19. So I think you got plenty of time, Fern. I was always working stream. I was just yeah. Most of them do, Fern. Most of them actually come back and let me know in January. Hello. Oh man, I know. I'm gonna stuff up this name again. Elise. Like Elise. Welcome back, Elise. David. Yeah, you know what it is. 6.5, right? All right, team. So we're going to get on with today. Today's main topic that I want to cover in probability is relative risk. I think that's almost the second to last topic that we need to do. And to be honest, I think by the time I taught it, maybe like half a session, like when I say half a session, half a period, and like about 9 years ago. So it is going to come back to me quite slow, but what we are going to do is we're going to actually work through this. There is a weird table set up there. So the first thing I'd like you guys to do is work out the table. I'm going to give you guys one. Now let's actually just go through the question, all right? So I'm going to go through the question, and the next one I'll actually get you guys to do it. No worries, Taylor. You're welcome. Pujana, happy to help. All right, so I'm going to do the I think relative risk, it's all about just putting the right probability on top of each other, and I always struggle with that because I don't know what the hell those 3 times more likely, 2 times less likely. I always struggle with that. But anyway, we're going to try and figure it out today. And so we'll get started. So with this question, what we have is we've got to fill up the table first. So Arya kept a record of how she traveled to school. The term had 50 days in total. She had biked for 28 of the days. So biked is going to be 28 of the days. And total is 50 days. So that means we've got 22 for the, there was a little shake. I wonder if it's the software. Damn it. Welcome back, Lizabella. Welcome, and welcome back to Taylor too. All right, so we got 28, 22, and 50. It says she was late on a total of 20 days, and 9 of these days when she biked. So that means we've got 9 here, and 20 of the days she was late, and 9 days she was late when she was on the bike. All right, so once we have this, what we're going to do is we're going to fill up the rest of the table. So when we fill up rest of the table, remember that if she is late 20 times, then that means on time she's going to be 30. And if you look at the bike, she biked 28 of the days. 9 of those days were late, which means 19 of those days she had to be on time. Then we figure out the bus. We've got 11 that's late for the bus, because 11 plus 9 is 20, and then 11 plus 19 is 30. A really good idea is to check all the numbers to see if the numbers all add up to the totals on both sides of the table. And from here we can kind of see that, yep, all the numbers actually add up together. So from here, all you've got to do is you've just got to match what the question's asking, and then we're good to go. So the first question, question B, well, question A was complete the two-way table, which we've done. Question B says calculate the absolute risk of being late to school. I think this is another way of saying calculate the probability that they're late for school. So out of the 50 days, she was late for, how many days was she late? She was late for 20 of those days. So I'm going to write that as 20 out of 50. You're welcome, Sega Memo. Bruno, 100% yes, that is going to be the last session in this playlist. So this is part 9. That whole center, spread, shape, analysis, all of those things is going to be part 10 when we do this during the holidays. Okay, so the next thing is calculate the probability that she is late on a day when she bikes to school. All right, so if we look at it, she is biking to school 28 days. And out of those 28 days, 9 of them, she's actually late to school. So that's going to be 9 out of 28. That's question C. Question D, we're looking at probability that she is late on a day when she takes the bus to school. So if you look at it, she takes bus to the school 22 times. And out of those 22 days, she is late for 11 of them. So that's going to be 11 out of 22. Hey, Ayush, this is just starting, we're just starting to go with this. So I'm just kind of going through this very slowly. So this is all we're going to be doing today. We're going to be doing about maybe about 3 or 4 questions of this. And then that should be good to go. TED night, we do it every Tuesday night. That's going to be level 1 on Tuesdays. Sundays and Wednesdays is level 2s, and Mondays and Thursdays is level 3s. Yeah, no worries, Ayush. Just hang around for the next 45 minutes and we should be good to go. Okay, so now here comes the next question, right? The next question says, and this is where I always get confused with. So we've got find the relative risk of being late when she bikes compared with when she catches the bus. So I'm going to put this as event A, and this is going to be event B. So basically what we've got to do is we've got to do A divided by B. Now the probabilities have already been found, because when we look at it, the probability of her being late when she bikes is 9 out of 28. And then the probability that she's late when she catches the bus, that's 11 out of 22. And what we're going to do is we're going to put this in the calculator to try and work out what the relative risk is. So the way we're going to do that is, I wonder if this will actually work. I just want to try it out. Yeah, no, it's not going to work. I definitely need to put brackets. Sorry, I was just messing with something. So we've got 9 over 28. That's not going to work. 9 over 28 divided by 11 over 22. So that's going to give me 9 over 14, or 0.64. So that means the relative risk is equal to 0.64. Now most of these questions, they always have explain in context meaning, like you've got to actually explain what that relative risk actually means. And so in this particular one, when we look at it, it is 0.64. So that means we can kind of say that there is a 36% chance less, like 36% lower chance that she will be late when she bikes compared to when she catches the bus. So we're just going to write that as a little statement. So chance of being late man, that's so frustrating, this whole glitch thing that's happening. Chance of being late when she bikes is about 36% lower than when she takes the bus. That is crazy glitch. Why does that happen? All right, so what I'm going to do is let me know if you people have any questions with this so far. Checking all the cables. I'm trying a new thing, but good job, doctor. Will you do level 3 probability before exams? James, probably not. I'm probably just going to stick with algebra and calculus, because I always struggle with probability word questions. Like, I don't mind the calculation stuff, but I don't know, maybe I'll see how it goes. All right, so let me know how you folks went with this. I'm going to see if I can get another similar question. And I'm going to get you people to try it out. By the way, these are all just generated by ChatGPT at the moment. So, you know, if you find that some of these questions are a little bit repetitive, that's because they, just trying these kind of questions here. All right, so here comes the next question, people. So there we go. Try that by yourself. I'm going to give you guys about 3 to 4 minutes. Give it a go, and then we'll go through the answers. Wow, 5 years ago, Hannah. That is a long time ago. What are you, like, you finished uni now, or like working, traveling? Nasi Al Nasi, I've already covered probability in, I think it's part 2 or 3 of this particular series. So if you go to YouTube and look up probability NCEA level 2 I'll change that to 10 hours. But if you look at that playlist, I think it's part 2 or part 3 is when I go through probability trees. I'll let you guys have a go at this, and I'm going to maybe in 1 minute, I'll just do the table and then see how you guys go with the answers, all right? How did you go, TS? That's all right, man. That's all right. You're welcome. All right, I'm just going to do the table at the moment and nothing more. So when I look at the table, we've got 60 total days. Yeah, it confuses me too, TS. And then out of that, 36 days was cycled. So that's going to be 36. He was late 24 days in total, so totally 24 days late. Of these, 15 were days when he cycled. So that means this is going to be 15. So we got 15 plus 9 is 24. Here we've got 24 plus 36 is 60. Here we're going to have 21 that's on time, 15 that's on time, and then 36 altogether on time. Hey Jaden, welcome. It's alright Jaden, we're just doing level 2 probability and we're doing relative risk. And we're going pretty slow at the moment because this is part of the original tutorial series. So, okay, so give you another couple of minutes, try the questions, and then I'll go through it at 8:22, all right? Another half a minute, guys, and then I'll go through the answer. Like when you guys see these relative risk questions, it's just learning which one to put over on top, and then you should be good to go. Yeah, Pia Naga, I haven't actually created a playlist for mathematical reasoning yet. I really need to do it. I think I'll just have to bite the bullet and just get it done. Because all the live streams that I do, it's like they get stored in that one big live stream playlist for each topic. The only topic that I haven't done is mathematical reasoning yet, so I should do that. But anyway, in the meantime, let's get back to these questions here. So what we have got is, to start off, absolute risk of Kahu being late to school. So late to school is 24 and out of 60 days. So that's going to be 24 out of 60. Then we're looking at question C. Kahu is late on a day and when he cycles to school. So total number of lates is 24. And 15 of them, oh, hang on. Sorry, did I get this wrong? Just want to double check. Kahu is late on a day. Oh, sorry, when he cycles to school. So when he cycles to school, that's like given that he cycles to school, that's actually 36 times he cycles to school. And the one that where he's late for it is 15 out of 36. Looking at question D, write upon the probability that Kahu is late on a day when he comes by car. So that is 24 times he comes out of a car, and 9 of them happen to be late. Bruno, I think in the last session we talked a lot about two-way tables. So have a look at part 8, and that should kind of help you out with the two-way tables. And question E is asking relative risk of when cycling. So that's when cycling compared to coming by car. So we've got 15 out of 36 divided by 9 out of 24. So going into the calculator, I'm sorry, but I'm just going to use the other number there. So that's going to be 15 out of 36 divided by 9 out of 24. Okay, and if we look at this one, this time we're actually getting a relative risk of 1.11. All right, and that means what we're going to say is, Kahu is 1.11. See, this is what happens when I write at the bottom. Something weird happens. No, that does not. 1.1 times more likely to be late when cycling. Blimey. Compared to coming by car. I'm just going to put coming compared to car. I mean, I'm not sure, Ranav, like, because I'm not actually marked, I've not marked level 2 probability, so I won't be able to say that. I mean, all I can say is, you can actually just say if more likely or less likely, and that should be more than enough. I don't know why you would need that other part. All right, give me 1 second, team. I'm just going to create another question, and then similar question. Yeah, I think you always use more likely or less likely. Well, Kieran, when the number is above 1, it'll be more likely. If it's less than 1, it's less likely. But it's like you got to look at the difference. So if it's like 1.11, that's like more likely, right? But if it's like 0.64, like in the previous one, then we say that it's actually 36. There's a 36% chance of less likely of it to happen. All right, so here is the next question, and this one, the tables is already going to be given, and hopefully my tablet is not spazzing. I don't know why it's doing that, but your next question should be popping up very soon. All right, so let's try this one here. I want to know why it does that. I'll give you guys maybe about 3 minutes for this. So we'll go through the answer at 8:30. Oh, sorry, Lucy, I completely missed your message there. I don't know if you're still here or not. Lucy, I think stats, I've got probability videos, just the exam video walkthroughs on my channel. I don't have the skills or any kind of live tutorials that I did for level 3 probability. The other person that's worth checking out is like Liz Nedden. She is quite amazing with stats resources. I'm not sure if she's got any updated ones there, but it's worth checking her channel out. You're welcome. I think, Abhi, you're on the right track for question A. Try question B and so on. 72 out of 600. Yep, keep going, mate. Keep going. No, I do not make scholarship calculus videos. Calculus scholarship videos. No, I don't do that. Check out Calc WLD. He is on YouTube. He makes scholarship calculus questions. Amazing guy. Know him very well, and he does an amazing job. Yeah, that's the one. Sned and Metz. Yep. Old colleague of mine. Okay, so let's start going through with this one. Question A says we've got absolute risk of having one or more cavities filled with a group who did not eat sugary snacks between meals. So that is going to be how many? Who that's having one or more cavities filled and did not. Man, I'm like, see, I get what you mean by, who was it that was saying, Bruno, trying to understand how the question goes. All right, so let's have a look. We've got one or more cavities filled for the group who did not eat sugary snacks between meals. So for the group, so this is the group who did not eat sugary snacks between meals. That's 600. And from that, 30 of them having one or more cavities filled. Yeah, so that's going to be 30 out of 600. That is the first one. The second one, it says one or more cavities filled for the group who did eat sugary snacks. So that's going to be 72, which is they're having one or more cavities filled. But the group was who did not. Wait, what did I mess up here? Who did, not did not, who did eat sugary snacks. These 600 kids had sugary snacks between meals. So that is going to be 72 out of 600. So if you look at this probability, 30 out of 600, I'm just going to write that as a decimal just because it's easier for doing relative risk. And then I've got 72 out of 600. That's going to give me 0.12. All right, so with that in mind, our next question is, what is this? Oh, thank you, Carbon, but you didn't really need to do all those things. I don't know what's a cat and a love heart doing there. C, calculate the relative risk of cavities for children who eat sugary snacks between meals compared. So sugary snacks is A, compared with those who don't is B. Now, if you look at the probabilities itself, the ones that eat sugary snacks, well, that's 0.12. And then the one compared with who don't, that's going to be 0.05. So we're going to write down relative risk is equal to 0.12 divided by 0.05, and that's going to give us 2.4. Now what that means in context is children who have sugary snacks between meals, and this is the annoying one, right? Just writing this very long sentence, are about 2.4 times. Man, this sucks. 2.5 times as likely to need a one or more cavity filled Is it this thing? Give me 1 second. I just want to try something. Compared with... Nope, that's not it. It's still buggy. Children who do not eat sugary snacks. painful. I hate writing those long ones. Good luck, Nakawaka. But let me know if you guys have any questions with this one, or if you'd like another question like this, let me know as well, and then I will put that through. Something trickier? All right, Samuel. Maybe we can go to, what do you call it? We'll actually go to exam questions, all right? So, where is my exam questions? You want a relative risk exam question. All right, from now. Where's these relative risk questions? Here we go. Oof, that's the relative risk question from last year was quite nasty. Like they literally put that as the end, and they wanted to actually do they wanted to do that with letters, which is just mean. Online youth. Okay, here we go. I think I got one. Oh no, that's too big as well. Hold, team, hold. Okay, what I might do is I might just put another question up similar to this one, and then what I'll do is let's just see. Okay, here we go. Let's do this one here. A little bit more trickier. So this is going to be similar question. All right, let's see. This one seems a little bit not from tables, so they just have like a set of what do you call it? Just questions with words, and you've got to try and figure out. So it doesn't have like a contingency table or a two-way table, so you just work out from there. It's a bit dark, isn't it? This question. All right, here we go. Let's try this one here. Part 9. Now I have seen questions like this, so here we go. Let's try this one here. So with this one, I think it's pretty much exactly like the two-way tables, but what I would suggest to you is, when you look at the absolute risk is just the probability. So it's kind of, sometimes question A and B is like giving you a clue as to how you need to do C. So if they ever ask you to do relative risk, is like they'll probably asked you to, in the previous questions, to find the probabilities. Anyway, I'll shut up. You guys have a go through this question, and then I'll go through the answer. Carbon, thank you for that. Appreciate it. That was really lovely. That I don't even know what half those things are, Carbon. But thank you. How much time? Let's go with give you a couple of minutes, all right? 8:41, we'll go through the answer. There's that stupid glitch again. Prasad, I thought you guys had your mocks already. Is your mocks in actually term 4? What do you guys reckon? Is this trickier enough, or one more trickier than this, or like one more level trickier? Oh, only for algebra and calculus. Interesting. You got 81.181818. Really? Did you round up the answers? Is that why, Jaden? All right, let's go through this question because 8:41 is up. So calculate the risk of being killed while swimming. That is 904 out of 45,200,000. Whatever that probability is, that's the risk of that. Then we've got risk of being killed while skiing. That's going to be 11 out of 45,200,000. Now, interestingly enough, I know that you can actually do it over the probabilities, but because in this case, both the population is the same, I reckon if you just go 904 divided by 11, that should pretty much give you that it's actually 82.18. Well, 82 times more likely you're going to be killed while swimming compared to skiing. But we still have to do it with the probability. That's the relative risk aspect of it. So we're going to go RR equals probability of swimming kill versus probability of skiing kill. Wow, this glitch is super annoying, man. I don't know where it's coming from. I've tried 3 different cables and it's just going berserk. What time is it? 8:42:35. Okay, I need to take this back to BB Tech and be like, guys, help me out. Okay, so we've got 904 out of 45,200,000 divided by 11 out of 45,200,000. And I guess, even if you put that 45,200,000, you still are going to get the answer of 82.18. You do need to show it. And once you show that, so you can actually say, yep, so a person is 82 times more likely to be killed while swimming than while skiing. Oh man, this is so annoying. Oh, good job, Mahers. 22 out of 24 in calc. Very nice. Okay, so one more trickier question. Continue. Let's go continue. All right, very last question for today. I think I find that when I'm writing at the bottom of the screen, that's when this thing starts going berserk. I get a feeling, because when I write at the top, I've got no issues. But when I go to the bottom, no, that theory is defunct. All right, sorry guys, I'm just generating the next question for you. Please hold. All right, here we go. This is going to be the last question for the today, folks. Let's give it a go. The absolute risk. Oh, this is tricky. I got 3 to, I think it depends. Normal distribution, I go to 4 decimal places, but 2 to 3 is all good. Hey, Matt Woodsell, how you doing, man? Like, you got to help me try and explain this question because I suck at probability, and especially when these tricky questions come through. Okay. I might actually go through with this one because I think once you kind of see it, you kind of will understand. So remember that when we talked about absolute risk, right? Absolute risk is like just like the probability. So if you say that probability of heart condition, developing a heart condition is 0.002. So what happens is, so let's say you follow this special program and it reduces the relative risk of getting this heart condition by 40%. All right. So remember, if it reduces it by 40%, then the probability of, see, this is one stupid thing. I don't know what's happening with the glitch, man. So lost my train of thought. But probability that now with the new after exercise getting a heart condition is going to be 60% of 0.002 because it's actually reduced by 40%. And I think this is like, if you remember when you do percentage decreases, you would actually, you know how you'd multiply it by, like you'd actually go 1 minus R over 100. Like if you increase 15% GST, you'd multiply it by 1.15. If you reduce something by 15%, you will actually multiply by 0.85. That's pretty much what's happening here. This is following, what is it? Exercise. Special program. So that means the new probability for the heart condition is going to be no longer 0.002, but it's going to be 0.6 times 0.002. So that's going to be 3 over 2000. Like, I always hate this thing. Isn't it like 1.2? So 1, 2, 1, 2, 3. So there we go. 0.0012. So that's the probability of the new heart condition. So this is pretty much what question A is. Let me know if you have any questions with that. I'm going to put some line numbers just to see how you folks go about it. Yeah, I think so too. Looks good. Okay, so now we do part B here. With part B, what's happening is the basic question is, on average, how many people per 10,000 would avoid developing this heart condition by following the program? So all you really have to do is, if you look at the, Anga, the reason I said it's special was because they followed the special exercise program. So special, I just didn't want to write it so much. You get what I'm trying to say. Special exercise program. Okay? So now, out of 10,000 people, you're trying to figure out how many would avoid developing this heart condition by following the program. So we're going to look at the original number. In the original number, we've got 0.002 times 10,000. So originally, we've got 0.002 times 10,000. That's going to be 20 people. All right? And then, if you look at when they follow the special exercise program, we've got 0.0, did I go 0.0012? Is that correct? Yes, it is. 0.0012 multiplied by 10,000. That's going to give me 12. So basically, what that means is 20 people were going to get the heart condition out of 10,000. But after following the special exercise program, only 12 of them are going to get the heart condition. Therefore, we've actually, we can say on average, 8 out of 10,000 would avoid the heart condition. Stupid glitch. Maybe it's time I buy a new tablet. All right, and again, I'm going to pause there. Let me know if you have any questions on which line that you might be stuck in. Let's shut this. Well, considering they did give me this, they did give me this in 2021. This is an old tablet. It's like 4 years old. But it's just got to a point where it's just like, it's just not holding. I mean, this is the only thing I actually use, so... Nope, doesn't want to even close that. All right, guys. Look, what's the time at the moment? Get out of here. Time is 8:53. All right, cool. That's pretty much it for today, folks. Samsung ecosystem recommended for the tablet. Now mine, like, I like the Surface tablet because it just does what I needed to do. But the problem is, like, I started, I was doing like what do you call those streams? I had set it up so that it was actually doing a network stream, and it was going good, but I just find that every now and then it just starts lagging. So I bought a capture card, and I try to feed the tablet straight into the capture card, and what I'm getting is this glitch, and I don't know why I'm getting it. Super frustrating. And it just happens randomly, and I've got no idea why it happens. Like I could be doing something completely, just normal, and then suddenly it just starts glitching. Like, no idea why. I even bought like a very expensive HDMI cable. I thought that would make a difference, but clearly not. Yes, it is, Akansh. It is the last week of classes term for us. Hey, by the way, don't forget tomorrow, folks. I need to set up all the links for tomorrow. So the t-shirt giveaway is tomorrow. I've set up, where did I set it up? Hang on. T-shirt giveaway, the way you need to do this, live. I'll show you guys how to get into the t-shirt giveaway, all right? So if you go to my home YouTube, well, just a home place, and click on live. If you click on live, you're going to get to this particular link here. Click on that, and I think at the top there's a little register button, like Google form that you got to fill in. Fill in the form, and then basically from there, what happens is we do the giveaway. Well, I think I've got the wheel of names set up here. This is what happens normally, the madness. Wheel of names, there we go. This was actually last August giveaways, all the people. Oh, I just saw Elisa here. Yeah, so but the trick is you got to be on the YouTube chat, all right? So when I call out your name on YouTube chat, you got to say present or something like I'm here. Then the t-shirt is yours. If you just put your name and don't show up, sorry, you don't actually get it. That's how the YouTube guys have actually made up the rules. And when I say the YouTube guys, I'm talking about the people that have been coming on the chat. That's their rules. So we go with those rules. So if you do want a t-shirt, fill in that Google form. At the moment, I got about 50 responses. So, 2% chance of winning. Fairly up there. Better than 1%. I don't know what your name is. How are you good at maths? I'm not good at maths. I just failed a lot in maths. So that kind of gives me the confidence to just keep failing more. So, oh man. So it's not the USB. The USB-C is fine. How long have you been studying maths for? Well, I stopped studying in 2006, but now I like to learn different things. So, learning how to make things and artwork. I've actually gotten back into my artwork. Make t-shirts at home. Zoe, give me a second. I can actually tell you exactly when I'm coming. Can I take a photo of the tattoo? You don't need to take a photo. It's already on Instagram somewhere. Where is it? I'm happy to help, Akansh. Let me find it. I'm sure I had it there somewhere, Taj. It was with the watch. I know that much because when I got that watch from Casio, I put one up with Infinity Plus One on it. Let me just find it. Where is it? What was like at the end of 2023, I think. Oh no, here we go. Found it. No, I didn't find it. There. That's the one. There you go, Taj. It's there on Instagram. I know when people are from OJCs is when they call me Subhash. The rest of the guys don't call me that. That's how it's so easy to figure out which lot of you is from OJC and not. Hey, YouTube guys, I'm gonna check out and hang out at TikTok for a while because I did do the level 2 playlist, and I don't want people to think that this is a long playlist. So I will catch you guys in the big giveaway tomorrow. All right, so YouTube, I'm checking out. Um, it's all right, PK. No worries, Samuel. You're welcome. Yeah, what's up, Nathan? Nathan, the giveaway is at 8 o'clock. So we oh, did I not show that there? See you later, Matt Switzel. And no worries, Bruno. You're welcome. Which one, Akansh? I know quite a few. Well, actually, I know two. Angad, I think it's so. What I would say is, I don't know if you have Gemini, access to Gemini or ChatGPT. You could easily put some of those questions in ChatGPT or Gemini and just ask it to give you more questions, but make it just a little bit more trickier. But also say that, yeah, there you go. You could take examples you do not know and ask AI. That's exactly what Maths with Cell would actually say as well. Yeah, so do that, Angad. That's probably the best thing to do. To not by using AI. Well, PK, this is for people that actually have learned everything else, and they want something more practice. Then it's too hard, man. Like, I'll tell you what, when they increase our salary as a teacher, we might have some time, or reduce our workload. We might actually have some time to create some resources. But no, I'm not going to get into that. YouTube, catch you tomorrow at 8 o'clock. That's when we do our t-shirt giveaway. And then, yeah, we will catch you later, YouTube. I'm going to hang out on TikTok for a short while because I'm doing some work. But yeah, see you guys tomorrow. As always, thank you for watching. YouTube will stop. Yes, and...